The velocity of a particle at time t is given by r dot is I hat plus 2t. Oh, this is still boring. Can I change this? I've changed it from the one in the book. The one in the book is too boring. Determine R as a function of time, position vector. Maybe I'll write the words so you get used to seeing the words. Determine the position vector when t equals 1. Guess what's coming, Ryan? Calculus first before you substitute. Yeah. Determine the position vector when t equals 1 if r equals I hat when t equals 0.
Isn't acceleration constant in circular motion?
No. Magnitude of acceleration is constant, but acceleration is a vector with a direction, and the direction is not constant.
Because the direction points towards this centre.
Correct. Which means the direction is always perpendicular to the velocity.
Yeah.
Perpendicular to the velocity here, but not anywhere else. Okay. I've got velocity. Pay attention to the dot. I've got velocity. I want position after 1 second, whatever it is.
Integral.
Correct. To work out my constant, I need more information. So they've told me if my position is I hat at time t equals 0. I'm going to need that. So the first thing I'm going to do is go r is the integral of r dot with respect to time. If you prefer, you can write the whole thing out. I hat plus 2t squared plus 2 j hat dt. I encourage you to write at least one of those lines so that it is clear that you know you are using calculus. Again, because you are required to use calculus, not the physics equations.
Would they give you the same answer?
Yes, as long as it's constant acceleration. Is this one constant acceleration? If I differentiate this to get acceleration, will I get a constant?
No.
So this one's actually not. So those equations won't work. Important, especially for your external exam. You must use calculus.
Yeah.
I think I told you that last time we did the other motion section. Yeah. Okay, so this is t I hat plus, who's going to do this one for me? Which year 11 student would like to do the integral of that for me?
Looking at me?
Yeah?
T3 over 3.
Uh-huh.
T to 2, T3 over 3.
Uh-huh.
And plus T.
Uh-huh.
2T over 2? No? Over 1?
No, it's actually over 1.
Over 1.
Plus constant. But here, my constant is actually a vector, not a scalar.
Is that always how it is?
Yeah, because I've got a vector on this side, so I can't just add a scalar to a vector.
Yeah.
I've got to be adding a vector to a vector. Okay, what do I know? At t equals 0, I hat equals t is 0, so I've got no I hat plus 0 j hat plus c. I've just plugged t equals 0. On the left, I know what I have to have.
Isn't it 2T?
Sub-zero.
If t is 0, what's this?
Oh, yes, so
Okay, therefore, my c is I hat. Oh, I wasn't putting the squiggles under the eyes, was I? I have to make sure my eyes and my c's don't look the same. Therefore, R is t plus 1 I hat plus 2t cubed on 3 plus 2t j hat. Does that make sense, Julia? Does that make sense, Ben? Make sense, Ryan? The only difference for you, Ryan, is this is a vector.
Yep.
Okay, what's the question actually to ask for? Determine the position vector when t equals 1. At t equals 1, R is 2I hat plus 2/3 plus 2. Okay, hold on. 2 2/3 j hat. That's pretty ugly, but you can write, what is it, 8/3 instead?
8/3.
Yeah. The single most important thing you have to remember when you do any of these questions is do the calculus before you substitute. Don't substitute this, don't substitute this until after you've done calculus. Why? If I substitute any of these t's in here before I do the calculus, I'm going to get a constant expression. Obviously then my calculus that I do next is going to be wrong. Do the calculus, then do the substitution. Always, always, always. How many times are they going to hear that?
100.
It's a lot. Always calculus first. Always do the calculus first.